Okay, in this video we're going to be covering Chapter 2, Section 3. This will be Venn diagrams and set operations. One of the things that you'll find under the Unit 1 tab is going to be some Venn diagrams. You should probably print out a copy of the one with the 2 circles and one with the 3 circles. Okay, this will be very helpful, especially when you're doing your exam. One of the things that I usually will do in class is I will provide a copy of this for you and your classmates to practice on. Let me show you an example of what I do. If you grab your Venn diagram and slide it into a protective sheet and grab a marker, you can label the information, like let's say this is A and this is B, and then we can go ahead and label things, so like 2, 3, 1, and so forth. If you do this, you don't have to print your Venn diagrams out over and over again. Just use a paper towel with a little bit of water or dry eraser mark, and you can wipe it off and reuse it over and over again. One of the things I do suggest that you do, what I usually do in class, is have at least 2 markers. And there is some Venn diagram simulations in my math lab that can help you with these. Okay, let's go ahead and get started with the lesson. Okay, so Venn diagrams, there are a universal set. In other words, in the entire Venn diagram is consisting of all the elements of the set is represented. Okay, subsets are represented by your circles, where we have one group or one subset. Okay, the population would be the universe, and then the subset would be the group within the population. We're going to use this Venn diagram to determine each of the following sets. First is the universe. So anytime you have anything in the universe, you're going to write down all the numbers that are represented in the rectangle. Okay, so here we have a 1, 5, 6, and outside of the circle is a 7 and 9. In subset A, we're going to identify the 1, the 5, and the 6. Okay. For C, it says a set of elements in the universe that are not in A. So you want all of the elements that are not within this circle. That only leaves elements 7 and 9. When we have 2 sets of, there are different types of relationships, okay? The first is you can have disjoint sets, where 2 sets have no common elements. An example would be Democrats in set A, and in set B would be Republicans, okay? Anybody who is not classified as a Democrat or Republican would be outside of both of these circles, such as independents or libertarians. We could also have proper subsets, okay? So inside the universe, if A is completely within set B, we can say that it is a proper subset, okay? An example is set B are the people who have children, and subset A are all the people who have exactly 2 children, okay? So not everyone has exactly 2 children. Another type of relationship is the equal sets. It's hard for me to identify this on here, but as you can see, I tried to use a blue pen to represent one set and a red dashed line to represent the other. Here it says that set A are the students enrolled at TCC. Set B are the students who took the TSI. All students who are enrolled at TCC must take the TSI. So here is an equal set relationship. The most common type of relationship we'll see are sets that have common elements. If set A and set B have at least one common element, there's an overlap here. An example would be set A are going to be the nursing majors at TCC Northwest Campus. Set B are taking Math 1332 this semester at TCC Northwest Campus. If I took a poll, I bet there's at least one student in here who is taking classes at Northwest Campus. If you're taking my class, you are. And who's a nursing student. Okay, so that would be in both. But not all the students in this class are nursing students. So let's go ahead and further that example. Here we had set A, nursing majors at TCC Northwest Campus. Set B are the ones at taking Math 1332 this semester at Northwest Campus. Okay, so here we have Circle A, which is going to be broken up into two regions. You have Region 1 and Region 2 within this Circle A. Region 1 would represent all the nursing majors at the TCC Northwest Campus. Okay, Region 2 would be, if you notice, it's both in Circle A, which represents the nursing students at TCC Northwest Campus, and it's in Region B, which are the students taking Math 1332 this semester at TCC. So not all nursing majors are taking 1332 this semester, only some of them are. Okay, but not all students taking 1332 are nursing students, only the part in Section A. Okay, so Region 3 are the students who are taking 1332 this semester, but they're not nursing students. Then you have the rest of the population out here. Region 4 represents not nursing majors at TCC Northwest Campus, and they're not taking 1332 this semester. Okay, so that's what that diagram would look like. Let's look at some other ones. We're going to use the Venn diagram to determine each of these sets. Okay, so in set A, if we look at the circle in A, we're going to represent everything in the circle A. One of the things that I like to do here is where I would use my Venn diagrams that I mentioned earlier. Okay, so what I ended up doing for this one is I'm going to go ahead and do a Venn diagram. It's going to be this one right here. It's a little bit bigger for us, but I'm still going to be looking at our notes. So the very first one says, what is in section A? Okay. One of the things we would normally do if we were in person is I would say, okay, this is the label of this circle. Okay, this labels this circle. So if I want section A, circle A, I'm going to circle the entire circle. Okay, this entire circle is part of the population in set A. So over here, I'm going to list everything that's in the green circle. A, B, C, and D. A, B, C, and D. Okay. Part B. Part B says the set of elements in B, but not A. Okay. So what I'm going to do first is I want the elements in B. So I'm going to go ahead and start with my circle, everything in B. But then I go on and say, but not A. So I'm going to look on my circle, that everything that's circled, and I'm going to say, is anything in here in A? A is this circle. This is in A. Remember, we don't want A. So I'm going to cross this out, and the only thing left is going to be E, which is what I have here. For part C, it says the set of elements in the universe that are not A. Okay, let's go ahead and do this one. So the first thing I'm going to do is go ahead and circle everything that is A. Okay, and then it says every element in the universe that are not A. I do not want anything in A. So that just leaves me with E, F, and G. So if I go back over here, I have E, F, and G. Okay. The last problem says the set of elements in the universe that are not in A or B. So in this case, it says that are not in A or B. So I'm going to go ahead and circle everything in A. I'm going to circle everything in B. And then it says the elements that are not in A, so everything that's in A I'm going to cross out. But then it says or B, so it can't be in B either. That only leaves two elements, which are F and G. I have that right here. Okay, let's go ahead and discuss the definition of a complement of a set. Okay, so when we have a set, in this case we're going to use set A, which is identified by the capital A. The complement is going to be notated with an apostrophe next to it. Okay, so this is not A. Okay, here's the definition in set notation. Not A, or the complement of A, is going to be an element X, where X is an element in the universe, and X is not an element in set A. Okay, so if we have the entire universe, which includes A, B, C, D, and E, and we know set A includes A and D, let's find the complement of A. Well, if A and D are in the universe and noted as set A, then the rest of the elements that are not in A are going to be the complement of A. So we have B, C, and E. These will be the elements in the complement of A. Okay. Definitions of the intersecting. What we're saying is A and, think of the word and has a N in the middle that is similar to this, B. That's that overlapping section in our Venn diagrams. If this is set A and this is set B, A and B is going to be right here in the center. So here it says an element X, where X is an element in A and X is an element in B. Okay? Let's find the following intersections. Okay? So here I'm just writing the elements in one set. You know it's a set because of the braces. And we're writing the elements in another set. Which are the elements that are in common? Well, they have to be in both. So if I'm looking here, I can see 1 is not here, 3, 5, 7 is here, so 7 is an element, and so is 10. Okay. For part B, we have our first set and our second set. So 1, not in the second set. 2, nope, and 3, not in the second set either. So in this case, we have no elements. This is an empty set. In other words, this would be like having a disjoint set, which we talked about earlier. This would be here. There are no elements in common. Okay. Over here, we have 1, empty set, 2, empty set, 3, empty set. So the only thing that we have in common is nothing, empty sets. Okay? So in this case, if you have a set and an empty set, you're always going to have no common elements in this scenario. Okay, now let's talk about unions. When you think of a union, I want you to think of an or statement. Okay, so here it says A or B. That means an element X, where X is an element in A, or X is an element in B. Okay, so what's the difference between and or? Well, this is a common example that I like to use. Let's go ahead and think about me at a wedding reception, and I tell my husband, go get me a plate of cake and ice cream. If he has 3 options, the first one being just cake only, and I told him bring me back cake and ice cream, am I going to be happy with just the cake? No, I'm not going to be happy. If I said bring me back cake and ice cream and he just brought me ice cream, no, I'm not going to be happy. The only way I'm going to be happy is if I say bring me back cake and ice cream and he brings me back a plate with cake and ice cream. Okay? But what if I said bring me back a plate with cake or ice cream? So if he goes to the table and brings me back a plate with just cake on it, Will I be happy? Well, yeah, it has one or the other. If he brings me back a plate with just ice cream, am I going to be happy? Well, with the word or, yeah, I am going to be happy. If he brings me back a plate with cake and ice cream, am I still going to be happy? Well, yes, I'm still going to be happy. So when you have the word or, you're asking for a lot more variety and a lot more options. Okay? When you have the word and, you're looking specifically for a certain things that meet both criteria. With or, it could meet one criteria or the other, or it could be both. So we have a lot more options with that or statement. Okay, so let's do a few examples. Now we're going to find the following unions. Here's one set or another set. So I'm going to be happy if it's in this set or if it's in this set. So what I'm going to do is I'm going to list everything in both sets. Well, I have a 1 here, 3, 5, and then I skip over here because it's 6. 6 is over here. 7 is over here. Then I have 10 is in both, but I'm going to pick it anyways because that's the plate that has both. And then I put 11. Okay? Example 2. Here I have 1, 2, 3, or 4, 5, 6, 7. So I'm going to list 1, 2, 3, 4, 5, 6, 7. I'm happy with anything in either of these categories. Okay? Over here, it has 1, 2, 3, or an empty set. So I'm going to list everything in the first category, 1, 2, 3. Our note here is when you have the or, it's going to be everything in set A. Let's go ahead and look at the next one. The next one has our universe, which includes A, B, C, D, and E. Our set A has B and C, and our set B has B, C, and E. Let's go ahead and fill out a Venn diagram for this one. Okay, so here's my Venn diagram. And I have labeled this circle A and this circle B. Let's go ahead and fill out the rest of it. Okay, over here it says in set A has the elements B and C, but also in set B it has the elements of B and C. When you're filling out these Venn diagrams, you always want to fill out the intersecting part first. So what's in common between A and B? Well, we have elements B and elements C. Okay, so if I look at just my circle for set A, I can see that in this entire circle I have elements B and I have elements C. There's no other elements, so I'm not going to put anything else in this part of the circle. Okay, over here it's saying you have B. Here's my B. That's this part of the circle. Here's my B. Here's my C, and I also have an element E, so which would be right here. Okay? All right? In our universe, we have elements A, which I do not have on here yet. So element is going to be outside of sets A and B. We have B. We have C. We do not have D, so that goes on the outside as well. And E is right here. Now, normally on a set like this, you're probably wondering, well, why do we have it completely like that? This is actually a proper set. So if I had a different type of Venn diagram, this entire circle would be all within set B. Okay, so let's answer some of these questions. It says first find A or B, and then notice it has a little knot here. Okay, so let's go ahead and do this one. First thing I'm going to go ahead and do is remember when it says the word or, you are going to include everything in the circle A and in the circle B. So the first thing I'm going to do is go ahead and say, you know what, I want everything in A and I want everything in B. Okay, this little knot says we don't want the stuff we just highlighted. We do not want it. So think of this little line as a little slash because those are the things that you do not want. The only thing left in this universe are elements A and D, which is what I have here. Okay. Now let's look at the next one. Here it has that and statement, so that means we want both. Okay. So if I'm looking here, It says A not, or the complement of A. So in other words, we're not looking for A, we're looking for everything outside of A, okay? So what I'm going to go ahead and do is I'm going to go ahead and circle this part here, and I'm not looking for A, I'm going to scratch those off, okay? Then it says the word and, okay? So when it says the word and, that means we are looking for the criteria that meets both of these, okay? So let's go ahead and circle everything in B, okay? Now it's saying, well, not B. So everything in B, not. Well, these two are already scratched. They'll stay scratched, and so will this one now. Now when I'm looking at all of this, the only things that are left is A and D, which is what I have here. These are the only two elements that are not A and not B. Okay. Another way you can do these is just by writing all the elements. If this is easier for you, by all means, go ahead and do that. But you do need to know how to fill out a Venn diagram. Let's go ahead and try a few more. We're going to start with this one, A and B. All right. And remember, this is looking for everything that's both. All right. So everything that's both in A and B. So that's this intersecting. If you can see, this intersecting both A and it's in B. 5 will be your answer for the part A. Okay. For part B, we're going to do A and B. Well, we already determined this is A and B, but then you're going to have the word not. Not means we don't want that part, we want everything else. So we're going to use 2, 3, 7, 11, and 13. And then don't forget the outside ones, which are 17 and 19, which I have here. Okay. For part C, it says A or B. So I'm going to go ahead and circle my A first. And then it has the word or, and I'm going to go ahead and circle my B. So remember, when it has the word or, you can use anything. You can use this circle or you can use this circle. So everything that's circled, we're going to go ahead and list. 2, 3, 5, 2, 3, 5, 7, 11, and 13. And that will be part C. Okay. For part D, you can see it's a continuation from part C. It says A or B, and then it has the not. So now what we're doing is we're taking everything in A or B, and we're scratching it off. The only thing left will be 17 and 19. So for D, it'll be 17 and 19. For E, it says not A or B. So let's talk about this one, because here is when it starts getting a little bit tricky when you have the or here. All right. So first I'm going to start with the not A. So I'm going to go ahead and circle everything in A, and it says not A. So I'm going to go ahead and scratch these out. This is A, and it says not A. So that means I would be happy with any of these elements. But when it says or B, that's when things change. Okay? So when I go over here and I circle B, it doesn't say not B, it says to include B. But when I look over here, 5 is part of B. So really, I can't eliminate this element. I actually have to keep it in. Because although it's not, we said not elements in A, the word or means that if it's in element B, we would accept it. So 5 would be an element that you actually would accept, okay? Plus all the other elements that we did not cross out. So for E, it would be 5, 7, 11, 13, and the two outside ones, which are 17 and 19. 17 and 19. This is a really, really tricky one, and you'll need lots of practice on those to get those correct. For part F, it says A and not B. So what I'm going to do here is I'm going to first go ahead and circle everything in A, and it says A. So I want to keep everything in A. But then on this one it says not B. So when I go to B and I go ahead and circle everything in B, I'm going to scratch out the ones that are in B. Okay? The key here, it says and. So it has to be meeting both criteria. It has to be in A. So here's my circle in A. I want these two. And it cannot be in circle B. So the only two elements that I want are 2 and 3, which I have the answer down here. Okay. These are going to take a lot of practice. I would normally spend 2 class days on this alone, just practicing 2 circles, and then eventually we'll do 3 on the next section. The next section says the cardinal number of the union of 2 finite sets. So this is the long equation, but I'm going to help you with this. It's basically saying for A or B, we're going to add up all the elements in A, plus we're going to add up all the elements in B, and then we're going to subtract the ones that are in both. Okay? The reason we subtract the ones in both is because, remember, this is an element A, so it's part of this circle. This number is also in element B, which is part of this circle. So we're essentially counting this number twice. So we have to subtract it 1 time. Okay? Let's go ahead and do an example, and this is how we would use it in real life. It says, according to the factmonster.com, among the U.S. presidents in the White House, 26 had dogs, 11 had cats, and 9 had both. How many U.S. presidents had dogs or cats? There's that word or. While in the White House. Okay, so the first thing we're going to do is go ahead and fill out the Venn diagram. I know you have the answers there, but let's go ahead and fill it out as if we didn't. Okay, the very first thing that we're going to be doing is doing the both. We always fill out this intersecting part first. Okay, since it said 9 had both, I'm going to put the number 9 right here. Okay, the next thing I'm going to do is go ahead and label. We have dogs here, and we have cats here. All right. So if I'm looking at dogs, we see that there was 26 presidents had dogs. Okay. So that means 26 needs to go in this circle. But we already have 9 here. So all I'm going to do is use my calculator, and I'm going to say, well, 26 minus 9, that means 17 had just a dog, 9 had a dog and a cat. So if I add these two up, it's going to add up to 26. Okay. Then I'm going to go over to the cat section, and I'm going to say, oh, 11 had cats, 9 had both. That means only 2 had cats. So 9 plus 2 is going to be 11. All right. Now over here it says how many U.S. presidents had dogs or cats. So what I'm going to do is add up every single one of these individually. 17 plus 9 is 26, plus 2, that means we have 28 presidents had a cat or a dog. Okay, that's how we would solve these. Okay, that will conclude this section. Just let me know if you have any questions.